truth table, mathematics. Also, we'll be looking at Leibnitz'S formula to evaluate a given function up to fourth derivative. So stay blessed and listen. Thank you. Please like and subscribe. Also share. I'll be very grateful. That's it. Yeah. This morning, this is what we'll be looking at. This morning. Okay. Good morning, and you're welcome. This morning, we'll be looking at rules for conjunction in terms of truth tables. Please, you are welcome to Remjock Maths. We are all here to solve, learn, and impart knowledge, and to know more. So you are all welcome. I discovered that in the university, students find it difficult to understand on how to construct a truth table. Right here, I'm going to teach you, break it down for you on how to construct a truth table as simple as ABC. There are rules that one need to know. So if I'm not be exposed to those rules, you will find it difficult. Is that clear? And right now, I will expose you to those rules. Not only just that, we are going to look at Leibnitz's formula to differentiate up to fourth derivative, how you can make use of it. I'll break it down for you. Please, I want you to like, comment, and share. I'll be very grateful. I love you guys. Okay, so let's proceed to look at it. Now, for an example, you are asked to, let me say, example, this is a question, construct a truth table, for P conjunction Q, all in brackets, disjunction negation R. Yeah, we'll be looking at something of this nature. Is that clear? And I will break it down for you to know it better. Is that clear? Look at the board very well. Yeah. So if you have any question, you ask. Okay, yeah. This morning, this is what I want to look at. How to construct a truth table for this logical statement. Amen. This is P conjunction Q. This is disjunction negation R. Is that clear? Before I move further to explain this, let me just explain this. You know, conjunction its notation is this. Not V, but this is known as conjunction. And in short form, it means and. And means conjunction. So it combines two statements. Is that clear? It combines two statements, just like Bayelsa is in Nigeria, and Kaduna is in Canada. Can you see now? So if we want to find the conjunction of this statement, is here. Look at it here. The and. Please take note. This is it. Is that clear? So it combines two statements together. So if now we want to transform it in this form, it means we now let P be equals to Bayelsa is in Nigeria, then Q will now be equals to Kaduna is in Canada. Amen. Amen. Are you seeing now? Are you seeing now? So it means the conjunction of this statement, this is it. P conjunction Q now be equals to this. Can you see now? Look at it. But that is not what we are here. Yeah, good morning, Parada, Zara. Where are you watching from? Which country? You are welcome to Remjok Mats. Okay, yeah. So, sorry for the breaking transmission. So, as I was saying, can you see now? So, that is that. Then, here, we have, this is the junction. It is denoted this way. This is the junction. Take note. Denoted this way. So can you see now? Yeah. So the junction means all. Look at the board very well. Look at the board very well. So if we want to look at example here, if we want to look at the example here, it means clouds will travel by air or land. Can you see now? Can you see now? Cloud will travel by air or what? Land. Can you see now? So if we want to look at it, P will be air. We may say let P be equals to air. Amen. And Q. And Q will be equals to what? Land. So now the junction of this statement is this. Is this. Take note. Do you understand? But that is not what we are here for. What we are here for, just to teach you how to prepare a truth table. Amen. I want to teach you how to prepare a truth table. That is what I want to do this morning. And okay. Yeah. Okay. Yeah. So as I was saying, and sorry for the break in transmission. So I'm here to consider, I'll teach you how to construct a truth table. Exactly. So here is the question. It said construct a truth table for this logical statement. P conjunction Q, disjunction, negation arrow. When you see this, this is known as, amen, negation. This is how it denoted. So negation means it's nothing strange. Negation is just all about the opposite of something. Just like negation of boy is what? Girl. Two of us. Yeah, negation of boy is girl. So when we say negation of plus is what? Negative. Two of us. Yeah. So since we are talking about truth or false, true or false. So if we want to say negation of true, it will be false. So take note of this. Amen. Do you understand? Take note of all of this. So I can now clean all this. Then we continue solving or carrying the truth table. Amen. Okay. Yeah. So far, so good. As simple as ABC. So before we prepare this truth table for this, I would like us to consider the rules of conjunction, but already we also have here disjunction, two of us. There is conjunction here, there is disjunction here, two of us. So what we need to do here is take note of this. The rules, as long as it involves conjunction, that it states that the conjunction of two statements is considered to be true when both statements are true and false otherwise. It means, and false otherwise, it means assuming we have, this is P and Q. Assuming we have T, then the conjunction of P, Q. P and Q. I want to break down this statement here, this rule, so that you understand it better. So that when we are preparing this truth table, you will not find it difficult. Amen? Okay. So now here, our P is true, right? Q is true. So the conjunction of these two statements, look at it, P and what? Q. According to the rule, it means here will be what? True. Here will be true. But supposing here we have T, F. Can you see now? The conjunction of these two statements, here is true, here is false. So you can now see that as long as here is conjunction, since the two statements are not true, here we are going to write what? False. That is it. Take note. Amen. Do you understand? Are you following? Do you understand? Okay. So far, so good. So let us consider the junction. It means the junction is the opposite of, since we have the junction here, the junction rule is the opposite of this. Take note. Is that clear? Let me write it on the board so that you'll be carried along. The junction rule. The junction rule. The junction, amen. The junction rule. The junction rule. It states that, amen. It states that the junction of two statements, amen, two statements is considered to be false. When both statements, amen, when both statements are false and true otherwise. So, can you see now? Look at the board. That is the junction rule. I'm breaking it down so that by the time we start constructing this logical table, this truth table, you will not find it difficult. Is that clear? That is why I'm taking my time to break it down. So here it states that the junction of two statements is considered to be false when both statements are false and true otherwise. So it means, for an example, it means if we have two statements, P and Q, this one is true, this one is true, then the junction of these two statements, that is P, the junction Q, amen? The junction of these two statements, it means here, as you can see now, true, right? P said is true, Q said is true, two of us. So now the junction of these two statements, as long as truth table is concerned, here will be what? False. Here will be true. T. Yeah. Here will be T. Why? Because it states that the junction of two statements is considered to be false when both are false. When both are what? False. So you can see that here is true, here is true. Both of them are not false. And true otherwise. So it means true. Take note. Supposing here is true, false. It's the same thing. Because the both statement must be what? False. So here is true. But here, false, true, false. That is when we can now remember this, that the two statements is considered to be false when both statements are what? False. This one is false, this one is false. So here will be what? False. So please take note. Is there any other question that you would like to ask before we proceed? Look at the board. Thank you. So that we can move forward. Any question that you want to ask? Do you have any question that you want to ask? Is there any question? Yeah, sorry for the break in transmission. Okay, I'm very sorry. So let's proceed. Let's proceed. So that is that. So let us construct this table. Amen. Let us construct this truth table. Here is the question. It says construct a truth table for this. So let's write solution. Solution P conjunction Q. Mind you, this is not U. This conjunction, then disjunction, negation, R. Yeah. So we want to construct a truth table for this logical statement. Is that clear? So how can we construct this truth table? That is what we want to look at. We'll break it down for you. Amen? Okay. Okay. Yeah. So far, so good. So we want to construct this truth table. First thing you need to do is consider the variables. When we say variables, we are talking about what is the P, Q, and what? R. They are the variables. Take note. So, how many variables are here? 1, 2, 3. True or false? Yeah. So, since we have 3 variables, it means we are going to consider okay, let me just present it in a tabular form. This is P, okay, this is Q, okay, and this is R, amen, okay, all over. It means we are going to have TT to 4 places, then FF to 4 places, T, 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 then F, 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 and F. Can you see now? But supposing it's 2 variable, you just do T, T, that is P, and Q. Then F, F. Then here will be T, F, T, F. This is how it's supposed to be. But here we have how many variables? 3 variables. Amen. So for the fact that we have 3 variables, this is how we are going to prepare the truth table. Is that clear? Since we have 3 variables. So T into 4 and F into 4 places. That is for P. Is that clear? Look at the board very well. Any question? Do you have any question? No question. So far, so good. So let's proceed further again to consider what is it called? Proceed further again to consider this. You know very well that here P, supposing is 2, here P, TT, right? FF. So here will now be TF, TF. True or false? Yeah. This is how it's supposed to be. If it is, yeah, look at the board very well. This is how it's supposed to be. So don't look at the board very well. I want you to look at the board very well so that we learn together. Amen. We learn together. Amen. Amen. So is there any question that you want to ask? You want to know? more, drop it in the comment section and I will be glad to respond to your question. Amen. Any question? Is there any question? Yeah, no question. So we can now proceed. So now, as I was explaining, I said supposing it's two variables. This is how it's supposed to what? Be, right? But since here we have three variables, so Q will not take this setting. Is that clear? TFF. But it's going to be, your Q will now be TTFF TTFF. Can you see now? Then arrow will now take the place of what? This. So here will now be TF, 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 TF. Amen? Yeah. We are good to go. This is T. Yeah. This is F. Any question, please drop it in the comment section. Do you have any question? Just drop it in the comment section. Okay, there's no question. Let's continue. Please, I want you to like, comment. Is that clear? Also, please share. Okay, yeah. So here we have what we have here, negation arrow. So let us proceed further to consider negation arrow. Negation arrow. Negation arrow. Amen. You know, I explained negation in the beginning of the class. I said negation means the opposite of something. That when we say true, the true opposite is going to be what? False. So here, arrow is true, so negation of arrow will be what? False. Here, arrow is false, negation arrow will now be true. Here, arrow is true, negation arrow will now be false. Amen? Here, arrow will be is false, negation arrow will be true. Here, arrow is true, negation arrow will be what? False. Here, arrow is false. Sorry for the break in transmission. Sorry for the break in transmission. It is the network, please. It is the network. It is the network. Yeah. Sorry about the network. The network is bad, yeah. Okay, so let's proceed. Let us proceed to know more. Yeah. So that is that. So now, what we need to do here is we have to consider this. We are able to consider this as a subject. Look at it here. Then we need to consider this P conjunction Q as a subject too. So let us expand the table to first P conjunction Q. Amen. Okay. Yeah. So this is where we need this rule. But it states that the conjunction of two statements is considered to be true when both statements are true. and false otherwise. Amen? Yeah. So it's simple as ABC. So what we need to do here is we have to apply this rule to find P conjunction what? Q. Amen? Do you have any question? Drop it in the comment section, please. Any question? Okay. No question. Okay, so let's proceed. Let us proceed here. So here, P conjunction Q, amen? P conjunction Q will now be, this is where you come. This and this two columns. This and this. Because P and Q, not arrow. Please take note. Always be careful. Is that clear? Always be careful whenever you are preparing or constructing a truth table. Always be careful about what is here. Mind you, here is P and Q, not arrow. So you must come to what this column, these two columns, P and Q. So we are talking about P and Q. Please take note. So now, what we need to do here is, if you can see what I am saying, P conjunction Q. So we go by this statement, amen. So here will now be TT, yeah. It means here will be what? T, because of its statement that the two statements is considered to be true when both statements are true. So you can now see that this is true, this is true. Come here again, this is true, right? So here will be T. Then come here again, this is true, and this is false. So what are you going to write here is F, amen? Yeah, this is true, and this is false. What are you going to write? F, amen? Amen. Then this is F, this is true, this is false, this is true. What are you going to write according to the rule? Here is false, true or false. This is false, this is true. What are you going to write is false, amen? This is false, this is false. We are still going to write false, amen? This is false, this is false. We'll still write false. Can you see now? Any question, please? Do you have any question? Any question to be asked? It means it means let's proceed further. So the final subject we are going to consider this truth table is the whole of this logic. Open bracket P, conjunction Q, close bracket, disjunction, negation, what? R. Is that clear? So it means we have gotten this. This is what this, and we have gotten this. So we should consider this. Is that clear? So the statement or this, or that is this or this. That is what it means. So P conjunction Q, disjunction, negation R. Yeah. Yeah. So far so good. Let us proceed to look at it together. Amen. So what we need to do here is, as you can see, is simple as ABC. Here is the disjunction. I explained the disjunction earlier on. I even write out the rule. The disjunction rule is the opposite of this conjunction rule. Take note. Since this one is talking about two statements is considered to be true, it means here is considered to be false, where both statements are false. and true otherwise. That is just it. Amen. Amen. Okay? I don't know whether you have a question. Drop it in the comment section, please. Drop your question in the comment section. It's okay? Yeah, so let's proceed to consider this. Let us proceed. As you can see now, we are talking about this subject and this subject. So what is in between them is all, which is the junction, right? So what we consider is this column and this column. Take notes, this and this. That is what we will look at, we'll be looking at. Amen. Always take note, because talking about P conjunction Q. So P conjunction Q, it means the two statements have to be what? False. The two statements have to be what? False. Otherwise, true. So look at this. Negations, arrow statement says false. Then P conjunction Q statement says true. So what are we going to write? What's supposed to be here is true. Yeah. Then the same thing here is true, because it is only false, false. You can write what? False. Take note. Here, false, false. You write F. Here, T, true, false is what? True. False, false, false. Amen. True, false is true. False, false, false. True, false is true. Yeah. So this is how it's supposed to be. Please, do you have any question? Any question? Any question? No question? You don't have any question? Yeah? That's nice. There's no question. There is no question. It's nice. Please ask your question. Here to assist you all. Any question? No question? No question? Okay, if there is no question, let's proceed to consider more examples. Amen. Amen. Okay, let's proceed to consider more examples if there is no question. So far, so good. This is how you are going to prepare your truth table. First thing, as I said, you consider the rules. Then consider also the variables, and also consider the notation. Is it negation that is there? Know how to interpret it. Is it conjunction that is there? Know how to interpret it. Is it disjunction that is there? Know how to interpret it. I think if you can take note of this thing I have mentioned so far, it will do you good. You are good to go. You don't have fear. But if you need a private class, don't hesitate to chat me up on this. This is my number, plus 234 7033, amen, 667737. Don't hesitate. This is my WhatsApp and call number. You can chat me up. Then I will teach you privately, either online or you want me to come to your home, I will do that. So, or for your children, can do that. It's okay. So This is how to prepare the truth table. So, as I said, if the truth table contains only 2 variables, you don't need to extend it to 1, 2, 3, 4, 5, 6, 7, 8. The extension will now be, here will be 2, TT, then here will be FF, as I said. Why? Because the variables are what? 2. Otherwise, if it is 3, this is how you are going to extend it. Take note. Thank you and God bless you. Well, let's move further to consider more examples, because not logic, but we want to look at PD, just normal PD, partial derivative. I will not go deep. Is that clear? Then after that, we'll look at Leibnitz'S formula on how to obtain 4th derivative. Yeah, it will do you good. Is that clear? Stay tuned. Okay, thank you. Oh. Okay, so far so good. Let us consider. Let's consider PD. PD. Oh, sorry. That's not differential equations, but partial derivative. Partial derivative. Amen. Okay. We'll just look at one example. Yeah. Here we have a question here. Show that show that z is equals to exponential minus t sine theta at z subscript subscript tt is equals to minus z subscript theta, and I z subscript theta equals to minus z theta subscript theta t. Okay, yeah, it's simple as ABC. It's not difficult. I will break it down for you. I know some of you who are not used to mathematics, you'll be asking yourself, what are you talking about? Z subscript tt and z subscript theta, z subscript t theta, and z subscript theta t. I will explain it to you. Is that clear? Yeah. It's okay. So let's proceed further to look at this function. We'll look at this function. This is I that we should differentiate partially with respect to z. How many times? Respect to t. How many times? Twice. That's the meaning of this. Then likewise, we have to differentiate this function with respect to theta. How many times? Here, 2. Then here, we should differentiate this function with respect to t and what? Theta. I'll break it down for you. Is that clear? Yeah. So let's write solution. Amen. Amen. Our function is z equals to exponential minus t sine theta Then we have to consider I z subscript t equals to minus z subscript theta. Yeah, let me explain this. The common notation that people know, both those who are not mathematicians, is, when you have z subscript t, this is also the same thing as partial z all over what? Partial t. Amen? Amen. Okay. Then, so if we have z subscript tt, it means this implies that this is known as partial square z all over partial t square. But in some textbooks, they call it CLAUDE. These idiots, CLAUDE. Yeah. So we are calling it partial. Is that clear? Okay? So far, so good. Likewise, I know you are used to these ones. Those that are going mathematics, if I'm not mistaken, they are used to this. Because not every lecturer or teacher will go deep to explain all these things. That this is also the same thing as, some of them, they are very funny. They just come, then, yeah. So, anywhere you see this, it's the same thing as this. Anywhere you see this, it's the same thing as this. But, yeah, you may ask, what of this? Let me explain it to your own understanding. Amen? This is the same thing as partial zt is also known as partial square z all over partial t dot partial theta. That is the meaning of this. And this is the common one. All of you know, two of us. And likewise, z subscript theta t is also the same thing as partial square z all over, partial theta, partial t. So this and this are the same thing, and this is what you have been seeing every now and then. Any question, please, before we proceed further to differentiate that function partially? That don't be surprised with the word show that z equals to, as long as you are not a mathematician, when immediately you hear proof that, sometimes students, their body just they dance like this. As they hear proof that, show that, yeah. So don't be confused with the word show that z is equals to this function, that is this equals to this. So what they want you to do, this is the left hand side, two of us. This is the right hand side. As you can see now, the right hand side has negative sign. So after taking your derivative, how many derivative? Twice. Then after taking your derivative here, with respect to theta, how many times? Twice. You should get back to this. That is what it means. And that is what you want to look at. Amen? So please focus. Listen very carefully. But I want you to do me a favor. Please like, comment, and share. I'll be very grateful. Is that clear? Okay. So let's consider this. Amen? Okay? Let us consider this. Let us consider this. Okay, yeah. So far, so good. This is the function, right? So it's normal differentiation that you know very well. Is that clear? That you know very well. But this one is not going to be the z all over whatever, because you hear partial derivative. So please take note. Amen? Okay, so now what we need to do is we have to differentiate this function at first with respect to what is here, t. So So if we differentiate this function with respect to t partially, we are going to have partial t is equals to, we have two functions here, but not really. The two functions are different variables, true or false. So we are talking about t, not theta. So since we are talking about t, we are going to concentrate on the function that contains t, not theta. So any other function will be held what? As what? A constant. Amen? Please take note. So it means this, we are going to hold this one a constant. Don't disturb it. Don't disturb this function. What you need to do is this function. Please take note. It means you are not going to differentiate this one. Just keep it, hold it. Amen? Amen. So what you are going to do, because with respect to what? T. So if we differentiate this idiot partially, look at it here. If we differentiate exponential minus t, we are going to have minus exponential minus t. Then use it to multiply this sine theta. So here we are going to have minus, amen, exponential minus t times sine theta. Yeah. Then, they say how many times? Twice. Differentiate the function. How many times? Twice. So you come back again, not you go back to this one, no. You come back to this one to differentiate this one again to make it twice, right? So if you differentiate this, the same thing, you will hold this one constant. Just focus on the function that contains t. So exponential, here we have minus exponential minus t. So if you differentiate exponential minus t, you are going to have minus exponential minus t. Then minus times minus plus. So here will be plus minus t sine theta. Amen? Any question? Please drop your question in the comment section. Look at the board. Just look at the board. Amen? Do you have any question? Yes or no? No question? Okay. So let us proceed further. Let's proceed. Okay? Since there is no question. Amen? It's okay. So we are able to satisfy the left hand side with this. Amen? So let us consider the right hand side. Let's consider the right hand side. This. So it means we have to differentiate this function partially with respect to what? Theta. Look at it here. So our z subscript theta will now be, it means you are going to consider only the function that contains what? Theta. So this implies that this time we are going to hold this one constant. True or false? Then any answer you arrive at, use it to multiply by this. Amen? It means you are not going to touch this one. Here is t, not theta. Or supposing it's theta here, you know what to do as a mathematician. You are going to use product rule, true or false. But for the fact that there is no theta here, that product rule is not necessary here. Please take note. I know those of you that are not mathematicians, that borrowed mathematics every now and then. As you first see this function, what will first come into your mind? That this function is product rule. Product rule is applicable only if we have z equals to exponential minus t sine t. Take note. Can you see now? These are the same function, but they have two functions inside. True or false? So this is where your product rule will be what? Needed. But as long as here there is no t, amen, but here is theta. This is just like, this is Musa, this is John. Yeah. So you treat them according to their what? Names. But supposing here Musa, yeah, we can apply what? The product rule. But here we have John, we have Musa, so we cannot do it. We cannot apply product. But this is the best option, best way to look at it. Take note, please. Is that clear? Okay. So now, here it means we are going to hold this one, constant exponential minus t. So let us differentiate sine t. These are trig functions. So take note. When you differentiate sine t, you are going to have cos t. Amen? So use it to multiply this one that you said, please, stay here, oh, wait for me, I'm coming. Amen? So you are going to have exponential minus t. As you differentiate sine theta, you have cos theta. True or false? Amen? Are you following? Yeah. So now, the other one, they said, is what? To second gravity, right? So here now will now be z subscript theta. Theta is equals to, yeah, the same thing. You differentiate this one to obtain this. So you hold this one constant. Come to differentiate cos theta. So when you differentiate cos theta, we are going to have minus sin theta. So use it to multiply by this function. So here we are going to have minus exponential minus t, then sine theta. Can you see now? You see the negative sign. So therefore, you conclude by saying that the left hand side is this. Amen? The left hand side is this. So the left hand side is now exponential minus t sine theta equals to minus. Oh, sorry about the network. Very sorry about the network. Okay, so can we proceed? We can proceed, right? So let's proceed further to consider the II, this II, the II. I hope I can claim this, but here, the only thing we can claim, we claim this and this. Yeah, for this to grow. Yeah, so let me claim this. Let's consider the II, and let me also claim this because we'll make use of this. And this, claim this. Okay. Yeah. Here, the II is talking about, we'll start using this one to obtain z subscript t theta. So it means our z subscript t theta is equals to, it means you are to differentiate this function with respect to theta. That's the meaning of this. Differentiate this function with respect to theta. So you hold this one constant. Amen? This is what you are going to hold. Hold this one constant. Then differentiate sine theta. We are going to have minus exponential minus t cos theta. Right? Then likewise here. This means differentiate this with respect to t. Amen? Yeah, with respect to t. So z subscript t theta is equals to respect to t, so it means we are going to hold this one constant. Amen. So as you can see now, we differentiate exponential minus t. We are going to have minus exponential minus t. Use it to multiply cos theta. So as you can see, the left hand side is this. So here we are going to have minus exponential minus t cos theta is equals to minus exponential minus t cos theta. Yeah, this is where you are supposed to stop. Any further question before we move further to consider Leibniz formula to evaluate a given function? Any question, please ask your question. If there is no question, we can proceed further. Or, as I said, that this is my number. Don't hesitate to call me or chat me up. +234 703366 7737. Don't hesitate to call me, take note or write it down, or reach out to me in case you want me to be your daughter or your son tutor, or your children tutor, or your nephew, or you want me to be your tutor. I will be very glad to have you. Take down the number. Always available. Is that clear? So any question, please? Do you have any question? Yes or no? No question. So it means we can proceed, right? Can we proceed? It's okay. So let's proceed further to consider this. Okay, amen. Yeah. And Leibniz formula will be the last thing we'll consider here today. Okay. So far, so good. Amen. So far, so good. They say use Leibniz formula to differentiate. Okay. Leibniz formula. Amen. I will break it down. Okay. Use Leibniz formula to differentiate amen, to differentiate f of x equals to, what is the function, x raised to power 5 plus 1 times x squared, x raised to power 3 plus 2x squared. Amen. Yeah. Up to fourth derivative. Up to fourth derivative. Amen. Are you following? Okay. So let's look at this idiot. It's simple as ABC. Amen. It's not difficult. Yeah. First thing, let us write solution. Then write down the function f of x is equals to x raised to power 5 plus 1 times x raised to power 3 plus 2x squared times plus 2x squared. True or false? Yeah. So I know very well that those who do borrow mathematics, first thing, because the functions are what? Multiplying. You want to use what? Product rule. No. But supposing they said just differentiate this function. Yeah, but there is a condition attached to this function. They said use what? Leibnitz'S formula to differentiate this function. Up to what? How many times? Fourth time. Up to fourth time. So what you need to do is we have to obtain our Leibnitz'S formula. Up to how many times? Fourth time. And how are we going to obtain the Leibnitz'S formula? Is this. Let's go back to our Pascal triangle. Because without the Pascal triangle, you will always find it difficult. Your ND or year 1, you are taught how to use Pascal triangle to expand expressions, most especially binomial theorems. True or false? Yeah. So here our Pascal triangle is needed. It said up to what? 4 times. So let us have it 1, 1, 1. Amen. The 1 plus 1, 2, 1. Then 1 plus 1, 3. 2 plus 1, 3. And 1. And 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1. Yeah. This is what we need. 1, 2, 3, 4. Up to what? 4th time. So we just need this coefficient. This coefficient. 1, 4, 6, 4, 1. You're almost done with the formula. I'm just trying to open your eyes on how to come up with formula for what? Leibniz formula. Is that clear? So since it is up to what? 4th time. But supposing they said up to 3rd derivative. So where your mind will go, you have to count 1, 2, 3. So this is where you stop. This is where you stop. This is where you stop. So you just need this. Amen. Then already the function, as I said earlier, is in what? The form of product rule, true or false? So it means our f of x is equal to uv, true or false? Yeah, uv. Amen. So what we need to do here is we now f of x is equals to, amen. Those of you that know how to use Pascal triangle, you know that the power is what? 4th derivative, right? It means here we have uv. It means the power of u will start from the highest power, which is what? 4. Then it will now what? Deiterate to 3, 2, and 1. Then v will now start from the power, will now start from 1 to the what? The highest. That is 1, 2, 3, and what? 4. That is what I want to do. As you can see now, it means with the help of this coefficient, 1, 4, 6, 4, 1. So it means use this one to multiply what is here, to multiply uv. So it means 1 times uv the power of u is raised to power 4, right? So we are going to write it this way. IV, two of us, that is 4. Then v. Then plus, because v is 1, the power of v is 1. Then after 1 is what? 4. Plus 4 times uv times u. So the power of u will now decrease to what? 3. So I times v will now increase. V raised to the powers of I, right? Then what we have here? 6 plus 6 times the same thing applicable. Okay, it's not necessary, we just leave it as prime. Yeah. So u will now be u prime, then v will now be prime, right? Yeah. Then what we have here, wait, IV reduce this, okay? Yeah, you're right. Okay, here will be 4. Okay. Here will be 4. Then v, that is times u prime, right? I think there is a mistake here. This one will be IV, right? Okay. Yeah. It's supposed to be. Yeah. Amen. I've seen a mistake. Okay. So here we are going to have v prime. Then plus 1 times what? This idiot, u times VIV. Chicken up. Amen. Okay. So fast simple. So now this is the same thing as our f of x. It means this is IV prime is equal to this times this UIV prime times V. Then here will be 4 U prime V prime. Then plus here will be 6 U prime V prime, yes. Then plus 4 U prime V prime. Then plus 1 times this U V I V prime. Yeah, any question? Do you have any question? Any question? No question. So far, so good. So now, as it is now, you don't need a prophet to tell you. This is what you are going to use. This is the formula you will use. So you should know how to go and learn how to form Leibnitz'S formula depending on the order of the dynamics. Is that clear? Very important. So now you don't need a prophet to tell you this is your U and this is your V, because according to the formula. So it means you have to differentiate this function. That is, your U will now be equal to x raised to the power 5 plus 1, and V now be equals to x raised to the power 3 plus 2x squared. Two of us. So I need to claim this so that to be convenient for us to, amen, for us to, okay, let me write it down here so that I can play this. That is FIV prime of x is equals to UIV prime V, amen, then plus 4 U prime V prime plus 6 U prime times V prime, then plus 4U prime V prime plus UV IV prime. Yeah, so it means almost done, but we need to differentiate these functions with respect to x up to fourth gravity, so that we'll just substitute it into the formula. So now what we need to do is u prime, we are going to have 5x raised to the power 4. U prime, we are going to have what? 20x raised to the power 3. U prime, we have 60x raised to the power 2. Then u iv, we are going to have 120x. True or false? Yeah, true or false? Then v, the same thing, v prime, going to give us 3x squared plus 4x, and v prime is going to give us what? 6x plus 4. Then v prime is going to give us 6. Then v iv prime is going to be what? 0. True or false? So what is add here again? Just for you to substitute in these values irrespective of their order, derivatives. That is all. So like this, amen, like this FIV prime of x will now be equals to what is our UIV prime is this 120x times v, the ordinary v is this, amen, x raised to the power 3 plus 2x raised to the power 2. Then what do you have here? Plus 4, that is our u prime is 60x squared. 60x squared. Then v prime is this 3x squared plus 4x. Now what do you have here? Plus 6 times our u prime. U prime is 20x raised to the power 3 times v prime is 6x plus 4. Then this is what it will just continue like that, amen, to this point. So I want to extend my gratitude to you all, to you guys, for giving me your time, a part of this class. Please, as I said, don't hesitate to reach out to me. Here is my number. I'm going to write it again and again. Amen. Should, in case you need someone to help you, mathematically, plus 234 7033 6677 and 37. Reach out to me. I know you want to ask of my name. This is my name. Celestine Babayaru, the former Super Eagles player. But football, you know, our country, I was a very good player those days. I played left. Yeah, I have assisted Nigeria. I was a very good player those days. Since football cannot favor us, we have to fall back to academy and where I am. Anyway, I'm just joking. I'm not the Baba Yaro. I'm not joking. Yeah. Celestine OC, just joking. So you can reach out to me. This is my number, my call number or WhatsApp number. Thank you and God bless you. Bye. I love you guys. Have a wonderful day. Thank you. My boss.